Yes, the problem with this is that the green yard is going to actually react to that. So the green yard will work with. See, the other thing too is that the green yard won't work in association reaction. It'll work with an alcohol. It'll work with a alcohol. Let's check. That's naturation.
And this part is just
No, this is a reduction. This will go across NaNO2. That's sodium hydroxide. Yeah, that's another hydroxide. That's similar to NaB3. Okay, so remember to make phenol, you can do that. You can do this reaction. So to make phenol, we use that aryl diazonium ion. Remember that? So how do you go from here to there? Water. Water. Then can you make this from benzene? Yes, the way we did this, we did this. This was NH2, and then this is from NO2. So how do you go from here to there? Yes, that's HNO3 and H2SO4. How do you go from the nitro group to the amine group? Yeah. So zinc and hydrogen, that would work. Because zinc is a reducing agent. So that would work. Or you can use iron. I think that you use iron in too. So I'll say zinc or iron. How do you go from NH2 to the diazonium ion? Yeah, so NaNO2. So this is an oxidizing agent. So then we make our phenol. So once we have our phenol, how do you add this group on there? Or do you want to put this group on first and then put this group on second? Or does it matter whether you do this one first, or does it matter whether you do this one first, the other one, or does it matter?
Oxidize. That would make it go meta instead of para. So we have to put on the OH first.
So are you saying that this group here is a...
No, wait, it's a moderate. It's moderate. Oh, I thought it was injected.
Yeah, so this is an active.
We might have to put the large group on first, just to oxidize to get acid.
So you're going to put this group on first before the OH group on?
I don't think it matters.
Yeah, okay. I mean, you can claim size and say, okay, if you put the big group on first, that means you get more of the para and less of the ortho. But we have, in any case, because of steric constraints, we get more of the para anyway. Okay, so I can tell that a few we were starting to zone out, so I'm not quite sure how much longer you can be able to last here.
I'm just getting in the zone.
Have we got any reactions where we can add on an amine to alpha carbon?
An amine to an alpha carbon.
From acid?
Yeah. Yeah, there was one way, because one way was to do this. If you have an imine, you can convert that to an amine.
But do we have a way to add it onto alcohol? So it's already an acid.
So how do you make an imine? How do you make this compound?
Primary,
Yeah. So George, you have a primary amine plus
Plus an acid.
not an acid.
Or carbon monoxide.
A carbonyl, yeah. So either an allyl or ketone.
oh yeah.
Okay.
Yeah, that's that nucleophilic addition. Do that.
There's no way to add it on like when it's when there's already an acid present.
Well, see, you can use benzene and any 3-carbon, but see, I didn't say you didn't have to have that amine on there already. Yeah. Any 3-carbon organic compound or less. It could be an amine compound already.
Oh, really?
Make it easier on yourself. Because I didn't say it has to be like, now if I said it was benzene and say propylene, then you could put you have to figure out how to put the amine group on it. I didn't say it's any 3-carbon compound, organic compound, unless it could be them, start with the amine already.
That's why I wanted to have like a oxidize that first. That's why I put on this big group first. So I can oxidize this to an acid and then put the H2 group. Fe is an oxidizing agent. What else we're using?
Okay, so does someone want to show their synthesis method to the group?
to start with, if we can't put one ring up,
I
that's
spilled the
the
whole
problem.
5-gallon bucket of water. I spilled it. But I just kicked it and then picked it up now. And then I'm like, oh,
That's-
Oh, you can do isolation.
How is that?
the whole 5-gallon.
Really?
2, 3 cars.
Fine, but I didn't think you can like have so many groups of.
Oh, I actually don't know either. I just
Oh.
did it.
You just.
But that was before I the alcohol is.
No, I consider this like an alkylation.
Is this a
An alkylation.
Are you serious?
I don't know if you can add like so many groups like on it.
That's an easy way out.
It is.
Because I actually thought that like right off the head.
Well, I just thought of this as like an argument. Like an alkylation.
That's why I thought too. I just didn't know if it actually works with all the times.
I don't know either, but that's what it is. It was just, I don't have to. What do you say? It says make it easy on yourself.
On your card? Put it on my card.
Yeah.
Put it on my card.
This is hard.
I wish I could marry you. I'm married Michael.
Okay, so what do you think of bond synthesis?
I'm new to it. I don't know if it actually.
No, because, see, once you convert the benzene to the phenol, then bonded, what kind of reaction is this?
Torpedo press.
Yeah, phenol press, alkylation reaction.
Is there a limit to how many groups you can put on the alcohol group?
Yeah, see, one problem with that phenol press, you get multiple substitutions.
So that would just be one product.
But technically that would
You
work.
can actually get other products too. But if you get other products, you just have to separate the desired product from the other products.
So it works, but not effective.
How do you add that longer substituent stepwise?
Stepwise?
Instead
Oh,
of-
so in other words, if you start with phenol,
I think you can only walk away from the
so actually you're saying if you start with this, how would you make the product? Yeah, how would you do that?
And the one I forget.
Yeah, that's right.
The smart users like we would.
Yeah, I look for what?
Would that work? Or would it form an alcohol that I just Okay, never mind, I don't have a good one. I like it.
That wouldn't work because there's acid present.
I don't know.
Okay, so, because see, one thing we can do is, see, note that one way to form that amine is do this, because we said that if you have this compound, that can come from this imine. We know how to make an imine. And then what's one way to make an alcohol? What's one way to make an acid? So we can make an acid from Yeah, so we can do a, yeah, so the conditions we need here are,
KML.
yeah, an oxidized agent, or we could go, another way to do it is to use a alcohol, okay? Yeah, we can use an alcohol. And the conditions we need in that case, it came in a 4. What's another way to make an acid?
Alkyne for alkyne.
Yeah, so we can take an alkyne and do those analysis. What's another way?
Can you do?
Hydrolysis of an amide.
Yeah, hydrolysis of an amide. Okay, so there's different hydrolysis reactions. Okay, so we have an amide. That'll produce the acid and an amine, or we can do a hydrolysis of an ester. That's another way. Or an anhydride, or let's see, amide, or a acyl chloride. And there's one more way, at least. We talked about it briefly in class.
CO2 and Grignard.
Oh yeah, CO2 and Grignard, that'll work.
Or,
Nitrile and H2O.
Yep.
Plus.
yeah.
Plus the RMGX for the nitrile. And what were the conditions again?
I thought H2O.
Yeah, H3O plus, that'll work. So based on all that, can you figure out a way to go from here to the amino acid? Yeah, so remember again, from here, to make the imine, we start with primary lead.
Well, actually, there's a sodium cyanoborhydrate.
Sodium
Cyanoborhydrate. And that's supposedly a carbonyl group, turns it directly into the C bond to an H2.
Okay. That's reducing. Hydrogen. They had, see that? I think that reagent is actually going through here first, and then it goes from here to there.
Even if you were to add the acid, how would you add the NH2 bond to the acid?
Yes, but yeah, is there a way to do that?
I only know the way of doing the NH2 with replacing the OH group with
Placing the OH group.
or actually turning the OH group into SOCl2 like a Cl. And then
Actually, we need to look up something here. Because this was from, let's take a look at this reaction.
it breaks it into two.
Yeah, this is actually from a previous
It breaks up
agreement.
into two acids. There's no triple bond acid. I just know.
Okay, let me see if I can find it on.
That's probably why. Because I just know that if it's
Hold on,
a
just a sec.
symmetrical
It might be on.
triple bond, then it's going to make two acids. If it's unsymmetrical, it makes one C double bond. So
It might be on this one.
ended up with CO2. It makes one C. Yeah.
from last year, and I think. Oh yeah, this one. The valine is an amino acid. Here's valine. So can you go from here to there? This, maybe that'll help us figure out how to make this compound. Okay, so start from here. Here are compound A, compound B, and then show the structure of valine. Basically, try that one.
Is this from a past final?
That was from last year's final. So you have CL and CL. Oh, no, what's the verb? Substitution. No, you have to figure this one. Up to there, there's fine. You have to figure a way, different way. Remember that AS3 is a
Yeah, that works. Might have to keep though.
And then when you get the nitrile, you can use H2O plus.
Where is that?
Okay, so we can do the same thing we did before. So here's our starting reagent or starting material, and here's our reagent. So where does, at which atom can a reaction occur in this compound? In carbonyl-carbon. Note that there's also an alpha carbon.
But it's the more the C.
So this reacts with NH3. And note that compound A, the formula is given C4H9, C4H9N.
So it forms an amine.
this an example of what you mean by instead of a line map, you have this in a thing?
Yeah. So instead of doing combining all in one problem, it'll be separate problems.
How many problems are there?
I don't remember, there's 4 pages.
And
Probably split into like many parts.
how much of it would you say is focused on the new chapter?
Let's see. Excuse well, we need to get this one.
Switching from like actual.
But he uses actually so good.
That's right, it is good.
It's good, what are you talking about? But I'm like, right.
Oh, wait, I like that.
All of them.
For summer.
No, it's yeah, that's what we actually do. The summer ones.